Hello, I'm Terry Gesualdo. Welcome back to La Dolce Audio and another Fireside chat. This one's going to be about design, how I've kind of come to design various things. So we're going to start with amps and then maybe move to speakers. Um, Speakers are simpler, you could say, in some ways. There's not as many. I've made them complex. I don't know how I do that. With my minimalistic approach, the minimalism is in the function and the circuitry. But in anything with design, the devil is in the details. The details are what make it. And so you could have a circuit, and I'm almost certain that there are other, well, not necessarily, but basically, if I gave you the basic circuit of what I do as far as a pentode goes, without the values, you'd say, oh, that doesn't look very complicated. That looks like a lot of other amps, and other amps could look more complicated than what I do. So that's a thing. All right, so let's talk about how I design. And this is kind of interesting because this kind of came into fruition over about a 10-year period from 2005 to 2015. And once I decided how I wanted to design, then that was just it. I tried various things in designing that a lot of other people do, particularly engineers, with simulation designing. But the problem with simulation designing is you're designing entirely for specs. That's what you're designing for. And so you're looking at specs and you're looking at everything. And the program is simulating as if it's real. And it's assuming that everything's perfect, that your 100 ohm resistor is actually 100 ohms, which would be a precision device. Same thing with capacitance and all other kinds of things. And if anybody knows anything about electronics, there are tolerances. You can do precision, but precision isn't necessarily going to get you better sound. So that's a thing. Now, when you know that, and you become a different kind of audiophile. In other words, you're like, yeah, the connector brand and type doesn't matter as much as, is it really copper? And what kind of plating does it have on the copper? And how thick is that plating? And so on. So you begin to look more at not expense, but what's really real. So that's just kind of something that I think that just kind of gets born out of being on this side of the curtain when it comes to audio and high fidelity and being an audiophile. And I'm a designer and maker of things as an audiophile simply because I could afford a few $100s a week to buy parts to make things that I knew how to make because I went to school for this stuff, than to spend the thousands and thousands rotating stuff through trying to figure out who made stuff that I liked. I was on that train for a little while. It's the way the world works. Okay, so how do I design an amplifier? Anymore, I'm just doing single-ended pentodes. That's my thing. I could do other kinds of amplifiers, but then the complexity goes up, and there are some benefits to it. But I mean, how complex do you want something? The simplest circuit is more complex than anybody would have any idea, because you're looking at several things all working together as a unit. It's a system. And just like a stereo system, all those things need to work together. But in an amplifier itself, you have driver tube, output tube, all the components that make the output tube and the driver tube work, and that's just a thing. Okay, so I start on the output. I first choose the output tube. and it's based upon what its specifications look like to me. And when it comes to pentodes, it's based upon, well, you know, how much of a constant current source can I make out of this tube, and will it sound decent with that? And constant current source is a current drive output. So I start with that tube, get that tube, and then I have these output transformers I got from Edcore years ago. I think they're called Tinkerbot output transformers. They have several, 10, I don't know how many. I've got push-pull type and single-ended type, and they have several different primary input impedances, and they're huge. And then they have a few, I don't know how, I can't even remember how many, maybe 3 output impedances for the speakers. And you just put them on a breadboard and you just start rolling through things and finding out what that tube likes. Now, when you're doing that at that point, you've kind of already just picked a medium area of output impedance, or the impedance of the primary of the output transformer, and you've picked that because of how the load lines look and how the distortion signatures look. And if you don't have a distortion graph, then you can make your own with a distortion meter. I have an old distortion meter, and you just kind of figure out where you kind of want to be with certain things and stuff like that. And after a while, after making mini amps, you kind of have an intuition of things. You know, you have an intuition of, this is what I like, this is my experience of what sounds good, so this is how I should start going about things. And so once you get that load impedance and the operating points with that impedance figured out, now you've got your circuit. So now you can start building the actual amp, and that means you now have to start with the output transformer. And I used to make my own output transformers at one point. Before, I had a few companies that I would buy them from. Jack Eliano at Electroprint, when he was doing stuff, he was so kind. People said, don't ask him to do this, he won't want to do it. But if the more of a repeat customer you are, the more willing he was to try things with you. And that was exciting on some levels. And he was an old school transformer guy, and he would always ask me the same question: do you want this to run cool, or do you want this to run hot? Because that, you know, how warm that core got and how warm those, and I always liked mine to run cool, which meant usually that load would drop the voltage more on them. So it was a thing. Anyway, and also I think, I don't know, there's other things to go with that. You know, so it just depended, and Jack would explain all those things as well. But anyway, I started winding my own, and I started in my research and other things and trying things and stuff like that. I found that I liked certain winding schemes. I liked bifill around secondaries. I liked heavy interleaving, which took a lot more time and could cause you to make more mistakes. There were several output transformers that I did not size the bobbins properly. The bobbins were too small, and it was really heaped up on there outside that bobbin trying to work. You know, there's ways of making a bobbin that's too small work, and that's precarious. It can be done, but it's precarious. I would never sell an amp like that because somebody dropped something, unless I like to do what they call can my output transformers, put them in a metal chassis and fill it with resin, and that damps the transformer. It holds all the laminations tight. And, you know, it's not great for heat, but if you're making low heat transformers in low heat situations, it's not a problem. I mean, what's high heat for the human finger to get a blister on is not necessarily high heat with electronics. Um, but you try to keep things lower heat because of thermal noise, and we've kind of talked about that before. So there's no need to go into that. Anyway, once you figure that all out, once you wind your own transformer, or now I'm having them made, once I figure them out on my own, then, now you're just going through component by component. What capacitor you want in this position? What resistor do you want in this position? And as it goes along, do you want a transformer couple or do you want a cap couple? And all these kind of decisions you're making as you're going through and making the amp. And you're going back to the input. And you're making it so that, things work together well. I like to describe a amplifier, and especially the tube circuit itself, the one tube circuit like the output tube or the driver tube. I like to describe it like a mobile hanging from a ceiling, right? And each leg of that mobile is balanced with the other ones. And so you take something or change something here in value on this one, and it tilts down. And this one over here was directly related to it, and so it went up. But these other ones, they change too, but not quite the same. But they all change a little bit. So the whole, as you're changing specifications of things and other things and picking components, everything starts to change. And now, components are interesting because each component itself will give you different things in the sound. And so I go through each component. I figure out what components I want, what components I like in various positions. And when I went from the UA 2.5 V1 to the UA 2.5 V2, that was the largest thing. There was a major power supply upgrade. That's true. But by and large, it was different component choices. In other words, I just didn't care as much about cost in those components. The V1 was made to be a really good sounding, inexpensive, integrated amp, and it still is. For what you pay, you get a lot sonically. There's no switches or anything like that, but it's not going to sound bad, ever. It's going to sound decent in everything that it's going to do. It's going to sound really good. Is it going to sound as good as the V2? Now, this is the thing. As an integrated amplifier, the V2 does sound better. But where the V2 and the biggest difference comes in those two amps is if you use the V2 as a preamp. Because it can, because I worked so hard to get that noise level down. What I didn't expect was getting that noise level down would do so much for the audio quality of the amp. And it's not, this is my personal thing, but it doesn't seem to me to be that big of a difference in sound. You still get the things that I like, but all my customers swear it's huge. To each his own. It's a thing, I'm so far beyond the point right now in my requirements to be able to enjoy music and to be able to engage with it and enjoy it. I'm so far beyond my minimum standards now. It's not even funny. I could live with the V1. I'm fine with that. I could live with the compact baffles, you could say. I really am into horns though, so the HL1 and HL2s are kind of more my thing. I would live with the HL1s easy. Those would be fine. But the HL2s, man, the things they can do. They're even now. Here I designed them, and they've been in production now for over a year. As far as, they had a slow start, and I did that on purpose because I wanted the first few customers to just tell me what issues there may or may not be with things. And we're still kind of figuring out some things. It's getting more and more expensive to ship out the parts, the 3D printed parts, because they're a little bit fragile for shipping. They're not fragile for the end customer generally, because who's going to drop a horn, But we'll get to the speakers in a little bit, but let's just finish the amplifiers. So the thing that I do and why I don't do simulation and things like that is basically I design for how everything sounds and operates. I go with current drive, but if with the you can get higher amounts of current drive, and because of other areas in the circuit that make it that amount of current drive, there's some issues that you can sound bad. So you have to balance it all out. You can't go with the highest level of current drive in the design of a pentode single-ended output transformer. It's not going to benefit you because it's not going to sound as good because of other factors. It's not the current drive that sounds bad. It's the other things you have to do to get the current drive that high that make it sound bad. So it's just a thing. And so when you're designing this, you're all doing it by ear. You're all trying to find, and so like it or not, my amplifiers aren't made to specifications, and they sound and perform according to my preference. If you like my amps, you probably like my sound for the most part. Very close to. I'm too far into the bush. And so that's a thing. So there's not really much more to say about amps other than they take to come up with a design. Even now, working full-time plus as a business, to come up with a new design is going to take over a year. It just takes that long for me to design an amplifier because I just have to take my time. I just have to hear it and listen to it. And the further along you get, the last few stages in finalizing everything takes the longest amount of time because you're listening to it for weeks. And I have a personal philosophy that works for that. If you listen to an amp for weeks and then go back and compare it to the amp you were listening to before, now the differences become so much more obvious. You have this sonic memory, so to speak, or this expectation of sound or whatever that you've developed over weeks, right? And so if you have a version here and you made this other version and you think it sounds better, listen to this version for like 2 weeks every day, then go back to this, and it'll be glaringly obvious the differences between the two amps and whether or not you like those differences, and or whether or not those differences aren't that big of a deal. I've had that happen a few times where I thought there was a bigger difference than there was, and as a result of that, then I'm like, well, okay, so now let's balance out other things besides this difference, like the cost of the difference and the impact that's going to have, or the impact it's going to have on other aspects of the design that you're considering other than just the sound. Sometimes there's practicality that has to be done. Sometimes, can you get these parts in the quantities you need so that you can do this? Or because some of it, to be quite honest, okay, I'll give you an example. I really like input inductors on the input of an amplifier. And I don't know that you can buy them anymore. I could probably have someone make them for me. But these input inductors are an inductive load on the input of the amplifier and its impedance, and usually they're air core, and they just create more of a swing on the input, and if you have, depending on what you have as a device that you're driving from, it helps those input chokes really help it work better. Usually you have an input resistor that sets the input impedance, and it also doubles as other things like the grid leak resistor on the control grid. So that input choke, or whatever you call it, I really like them, but nobody makes them. and they're expensive. And so I've been able to buy a lot of them, new old stock, and they're just a rare part. And the sound difference between them and a resistor, depending on what you're driving from, what kind of source you have, can make a huge difference in sound. And it really affects things you would not think it affects. And it all has to do with that previous component, whether it's a digital source of some sort, a CD player, a phono preamp, or whatever it is. And if it's a phono preamp with, an output transformer on it, then that choke is going to look like, in some ways, more like a speaker. And so that component that's driving the input of that amp is going to really change how it behaves. So I like them. I really like them, but not a lot of people do. Anyway, well, I don't know. I mean, how many people have listened to those? I don't know. There's also, you could do an input transformer on an amp, and they're teensy and little. They are tricky to get right so that you don't have any oscillations and things like that, but they're very nice. They're very nice. So what that does, that affords you a low resistance for the grid, but a high impedance on the input for the AC. So it has advantages. Now I tend to like R2R DACs, which really like a high impedance to drive. They sound, the higher that impedance, the more they sing, and they can do some pretty incredible things. An R2R DAC, when it's set up right, can just be a really incredible thing. I mean, the holography of it, of the imaging and what it can do with that, the sweetness, the smoothness, the naturalness, realism, all of it, when an R2R DAC can just be at the pinnacle of audio in many ways. And I have to think some of these super expensive DACs are probably in that realm of things, or they're doing something like that. I know a lot of these DACs have tube outputs on them and things like that. It's just a tube output. They could leave that out, and then sell a bridge, a vacuum tube bridge like Modrite has, and do the same thing. It's just integrating all that, the tubes in with the DAC. The DAC is not using tubes to create what it's creating from the digital of the audio. All right, so for the next few minutes, let's just talk about speakers and speaker designing and stuff. Last thing I'd ever thought I would be doing when I started this business as an amplifier business was making speakers or selling speakers or designing speakers. I've done that for years. I've put my dues in, you could say. I know how to do it. I just know how to do it. I was going to say something, but I thought, wow, that sounds arrogant and other things, but I'll just say this. I wish some others knew how to do it the way I know how to do it. You can see other people designing speakers and you're like, oh, if they only did this little thing, it could be so much better. Why don't they do this or that? So on. Yeah, it's a thing. What are you going to do? I do everything the hard way. I don't know why. It's just a thing. I'm a minimalist when it comes to certain things, but other things I cannot compromise. However complex they need to be, that's what they need to be. I'm not going to worry about it. All right, so when designing speakers, I have my personal philosophies. One is, if you're using a passive crossover, it needs to be as simple as you can get it. It needs to be to where it doesn't shift phase too much. And so that's kind of how that's partially how we got into all these mechanical acoustical means of controlling the drivers. But it all started with getting more bass out of a driver that could go below 30 hertz in an open baffle situation. That's what it started out as. You want more bass. And the claim was that everybody just didn't like is open baffles don't have bass. So I'm like, I got a solution for that. I know how to get bass out of an open baffle. And it was taught to me by Siegfried Liekwitz. And he didn't do it. He didn't use it. He'd used other means. But to get depth of bass, it all comes down to one concept. And that one concept is used in the drivers themselves. It's used in the designs of the enclosure or the baffle, and it's used in horns. And it's basically mass loading. You need some level of that loading for that driver to really put out some deeper bass. That, and then everything else needs to be structured around it. So that's that. This is a concept. This is a pretty fundamental, in my opinion, fundamental concept of how a transducer operates within frequencies, with certain frequencies. So that's a thing. To get deep bass, we're compromising really high sound pressure levels above 100 SPL. You know, there's ways of doing what I do at higher SPLs, but I've compromised it for many factors. So that was the first thing. Then after that, the second thing was just, well, we can use this because it does and responds these ways. We can use it in this form or fashion and so on. And then I've known about lenses for the longest time, horn lenses. I love horns and lenses. I thought, why can't we make this variable so you can control this more and get the pattern within your room? You have a bigger room, that lens can come out a bit more because the room's not going to be as involved as a smaller room. A smaller room, you can put it closer together. And we're going to talk about that in the Open Baffle video series. Right in the very beginning, we're going to talk about it. So, speakers themselves, simple crossovers, acoustical mechanical means of manipulating and using the drivers to get the best out of them. High sensitivity for whatever reason really kind of goes hand in hand with engagement and immersion when it's done well. Unfortunately, most of the PA companies doing high sensitivity for cost reasons have created more of a bad reputation for horns and other things than a good one. But it's all a matter of money, what people want to spend and how. So that's about designing. That's the fundamentals of what I'm considering and what I do and how I design things. And I'm hoping others see this and say, oh, I use that. I do that. I did that. You know, I'm kind of wanting to know. I've been designing and doing things in a bubble for so long, and partially that was on purpose so that nobody could accuse me of stealing something as far as a design or intellectual property. I just stayed off the internet for a time. And if I'm not there, and there's no cosmic record of me being a member of a forum or something like that, or viewing a website or anything like that, then nobody can prove anything and nobody can really claim anything. And I ended up achieving certain things on my own. I didn't even know a constant current amplifier was a current drive amplifier until just like 2 or 3 years ago when I read S's book. I'm like, I didn't know this had a name. I've been doing this for 15 years. You know, it's what I like. And now I know. And now I know how to measure it. You know, I didn't necessarily know how to measure it. I mean, you do and you don't. Because, well, you know how to measure it, but having a standard that you're putting it up against, similar to the standard of voltage drive, which is damping factor. So you have over here with current drive, you have current drive index. Over here, CDI. Over here, you have damping factor, voltage drive, current drive. You have the means of quantifying them. And they're both a way of quantifying them in relation to output impedance. They make the output impedance of an amplifier make sense based upon the average 8 ohm speaker. So 4 and 8 ohm speakers, you're going to have different damping factors and different current drive factors with each, but they're kind of opposite. So you have to understand how they're opposite and how they oppose each other. Anyway, I hope you enjoy your sound today. I hope you didn't mind too much of my rambling here in these videos, making them 30 minutes long. They all, I'm not trying to make them 30 minutes long. At the 30-minute point, I'm like, this is getting long. Maybe I should remake this video to make it shorter. And I've done that a couple of times. I've been able to cut 5 minutes or 10 minutes off a video just by saying, yeah, I just wanted to say this, and I can just use a few sentences. Well, I didn't need to ramble that much. Now you'll notice in some of my videos, the dogs bark, the planes fly over, the garbage truck goes by and it backs up and it does its beep beep thing. And so these are just raw videos, one take raw videos, and a lot of that noise I just ignore. And if you guys can tolerate it, all the better. It's about the content, not about the production. We'll probably get into production more and more. Oh, this is another thing. I should tell you this at the end of this video. You may notice the last video looked better again compared to the couple of videos previous to it. And that's because I stopped using the editing software. I would use the editing software, even if I really didn't edit, to I don't know, make the video with. I would just use it. And anyway, it was making I think it was downgrading the quality of the video, because I'm taking these in 4K, and I think it was downgrading it below HD, high definition. So I don't know. Anyway, so I'm getting a new editing software, and hopefully that won't do that, and we'll go from there. But this Win Movie Maker, I was using that. I paid money for it. It should be decent. You would think that with that kind of money you spend on something, whatever. I don't know what it is. I get so frustrated with things. It's a thing. It's a good thing I can laugh at life a lot. I try to laugh at life as much as I can. So anyway, I hope you enjoy your day. I hope you have good sound, and just ask questions in the comments. I'll try to answer them the best I can. I can't give too detailed of answers, but when those questions come up, it tells me, well, maybe I need to include that in another video. Maybe we need to talk about that. Sometimes I'm like, oh, that's a whole new video that we need to talk about, because that's quite complicated, or it's more extensive than you would think. So leave comments. Comments are great. It helps me out a lot. I can see the views and other things. I'm not going to beg for subscribers. What's the point of that? Here I'm rambling again. Have a nice day. Hope you enjoy your sound and your music. And if I can help you do that more, I'll try. Just leave a comment. Have a nice day.